Hello there, guys. We have mentioned the term isotopy a number of times in our previous lessons. In each case, we gave a general overview of the idea of isotopes, but in this lesson, we will dive deep into isotopes and their nature. Now, isotopy is a phenomenon that arises when atoms of an element have the same atomic number but different mass number as a result of the difference in their number of neutrons. Atoms of elements that exhibit isotopy are called isotopes. This phenomenon was noticed with the use of a mass spectrometer. And a mass spectrometer, as we mentioned in our lesson on the atom, is a device that can be used to measure the mass of an atom. With the aid of this device, atoms of some elements were measured and seemed to have different masses. It puzzled scientists for a while, but then they realized the cause was a difference in the number of neutrons in the atom. To further explain this, I am sure you still remember how to get the number of neutrons in an atom. The number of neutrons in an atom can be obtained by simply subtracting the number of protons in the atom, which is the same as the atomic number, from the mass number of the atom. So, for an atom like aluminium with atomic number 13 and mass number 27, the number of neutrons present in aluminium atom will be 27 minus 13, which equals 14. It is also important that we note the easy method of denoting isotopes of atoms. To easily spot an isotope, we represent atoms of an element in a specific way. The symbol is used to show the element, the atomic number is written at the bottom right of the symbol, and the mass number is written at the top right corner of the symbol of the element. With this knowledge, we can easily denote isotopes and determine the cause of the isotopy. Hydrogen has 3 isotopes: protium with mass number 1, deuterium with mass number 2, and the radioactive tritium with mass number 3. They are written as hydrogen 1,1, hydrogen 2,1, and hydrogen 3,1. It is very lucid that the distinction in these isotopes of hydrogen arises as a result of the differences in their number of neutrons. Now, protium has 0 neutrons gotten by subtracting 1 from 1. Deuterium has 1 neutron gotten by subtracting 1 from 2. And tritium has 2 neutrons obtained by subtracting 1 from 3. Chlorine, on the other hand, has 2 isotopes, chlorine 35 and chlorine 37, which are written as chlorine 3517 and chlorine 3717. It is clear that the distinction in these isotopes of chlorine arise as a result of the differences in their number of neutrons. Chlorine 35 has 18 neutrons gotten by subtracting 17 from 35. While chlorine 37 has 20 neutrons gotten by subtracting 17 from 37. Another important thing to note is that isotopes of an element will still have the same chemical behaviors but different physical behaviors. Their chemical properties are identical because the only difference in the isotopes are their number of neutrons, and it is known that neutron number has no effect on how atoms of elements react. However, the neutrons are just as heavy as the protons and increase the mass of atoms. This overall increase in mass affects the physical properties of the isotopes of the elements. And that is why a water molecule which contains the deuterium isotope of hydrogen instead of the protium isotope of hydrogen is referred to as heavy water, written as D2O. This is due to a significant increase in the mass of the water molecule. Isotopy is a very important phenomenon in chemistry, as more than half of the elements in the periodic table exhibit isotopy. So it is superb that you now have a good idea of this interesting phenomenon. See you in the next lesson, where we will see how isotopes of an element contribute to the adopted relative atomic masses of these elements.